Oh.
Disgusting.
Dude, I was on the camera. Man.
Oh my word. That was.
You're like a baby.
My whistle
You
attempt.
can't hold anything in your mouth.
Worst, I've never had my son do that in 16 months of his life. I've never seen something like that.
Did you get it all over the table?
Yeah.
No way.
Oh,
Where's the disinfectant?
oh my word. I don't know where all our spray.
No, okay, you did.
Don't
Okay.
ever whistle again, or
Still.
attempt to whistle
Just
again.
don't ever breathe again.
Seriously.
All right, inverses.
Not gross.
We're off to a great start.
That's what I told
today.
Bonka when I accidentally drew on myself and I cleaned it with spit. That's what my grandpa would do anytime he would say, "You got something on your mouth," he would lick his finger and tell him to get it off.
I don't know.
Stop, Vincent, go away.
Make sure I'm moving like
Vincent, no nasty. Nobody does that.
I'm sure people do that.
Nobody
Walnuts with
spits it
dry-
out and then does that.
Wait, I see the spitting.
Okay, so if you have a function and you want to find its, not a function,
Yeah.
a matrix and you want to find its inverse, matrices and their inverses, again, these are going to be with square matrices. So like determinants only do square matrices, right? 2 by 2s, 3 by 3s. We did not venture into 4 by 4s, but
Oh no, we're doing it.
no,
Okay.
you could easily do it with a calculator, but 2 by 2s, 3 by 3s. You can also do, we'll talk about how to do determinants using minors, which is in 16.7, I believe. But inverses, we're just going to work with 2 by 2s for now. We're not going to venture into 3 by 3s with the inverses. So that's really nice. So to find an inverse, you take your matrix A, B, C, D, and it's 1 over the determinant of A. So you got to find the determinant of A, which remember is diagonal minus diagonal, times then swap your A and D, and then change the sign on B and C. So you don't switch B and C, you just change the sign on B and C, B and C, and change the A and this, flip the A and the D.
That's advanced.
Okay, so let's do a numerical example for this, and then we'll do a couple applications for this as well. So find the inverse of the matrix, and let's go with
Lock it.
5, 3, 2, 1. Now, what they'll want here then is you're going to go to find the inverse, you're just going to follow this. Okay, 1 over determinant. Now we can mentally do the determinant, I think. 5.
5.
Oh, I thought that was multiplication. Man, I'm really mixed.
How do you find the determinant?
6.
You guys did all the determinant homework yesterday.
I did.
I
I
did.
don't remember.
Find the determinant of 2 by 2.
Is it 5 minus
5 minus 6.
6? Okay, plus or minus
Oh,
minus
yeah.
6.
Oh, wow.
Yeah.
Painful. 5 minus 6 because it's 5 times 1 minus 3 times 2. Okay, and then you take your A and your D and you swap skis,
Xbox keys.
right? A and your D and you swap, so you're going to go 1 and 5 there. And then you're just going to change the sign on the 3 and the 2, so -3, -2.
-3, -2.
So then that inverse you would distribute in with this negative, what is this distributed in?
Oh.
Negative 1.
-1.
What kind of multiplication do we actually call that? Not distribution, but starts with an S.
Scalar.
What?
Scalar.
Scale.
Mm-hmm. Ha.
So it just made like changing the signs.
In this case, changing the signs is a negative, yeah. All right. So there's your inverse right there. Now, if you have an inverse, say like this, or I said find the inverse, and we have what's your first step?
1 over determinant.
Yes,
Plus
one over determinant, not plus A.
Oh.
1 over the determinant of A.
Oh, okay.
Um,
always forget I have to like gear up for teaching this class.
Wait.
I forget the clientele I'm working with.
I know you go
It's
from
so
like,
you go from so low in calculus, those kids, to like you guys here that I forget. Like,
Oh yeah. We
you go from
are.
like people like
Almighty.
Gabriel and Zach to
Yeah.
geniuses like
That
us.
just zero.
Yeah, because zero
But
comes.
that doesn't work, does it? No.
okay, very good. We got there.
Yeah,
It does not exist. Okay, so you can just stop there when you get to that determinant of zero.
Then
There
you
is no inverse for it. Okay? Now, use matrices to solve. In this case, it's very inefficient to go this method for solving these. But the point is introducing that you can use matrices to solve systems of linear equations. For our purposes, though, it would be inefficient in the end because you just solve using systems of linear equations. Do you remember the ways to solve systems of linear equations? We had
Graphing method.
graphing,
subtraction,
subtracting.
Calculator.
substitution.
Yeah, then the fourth one would be a calculator. But algebraic, and those would be the three. Good, nice. That's encouraging. You guys know something.
Yay.
Hey. So if we're given 3x plus 2y equals 5, all right, then you're given 3x. Oh, let's go with minus y equals 2.
How do we use matrices to solve this?
Right. So again, if I said, hey, just solve this, you would say, I'm not going to use matrices, just going to subtract the bottom one and be good to go. But if I said, hey, use matrices to solve this,
We're screwed.
what you're going to do is you're going to set up a coefficient matrix. Okay, and that coefficient matrix is going to be just the coefficients. What are the coefficients given to us?
3, 2, 3, negative 1.
3, 2, 3, negative 1. And then you're going to have a variable matrix. And that's just the two variables you're using, which are x and y. So if x is coming first, or if it was a and b, I think all of ours are going to be x and y. But if this was a and b, you would do, a, b, you would go a, b like that. Okay. If for some reason this was switched and this was y and then x, then you would go y and then x.
Okay.
Or flip around, then set it up. Equals a constant matrix.
What is a constant? I was wondering that on the PSAT they were talking about that.
Oh gosh.
I think
What's a constant?
So one, it's like the number that stays constant in the equation, like with functions. It's like the
It's a number that doesn't have a variable.
yeah. It's
Stays
yeah.
constant.
Okay.
Who knew?
Some of you have a constantly annoying personality.
Why are you looking at me?
There's only 3 of you. And I'm looking at all of you.
Okay. Good.
Not stating any of you.
Well,
If you feel like I'm looking at you, there may be a reason why.
we make you.
Because you told me you hope I die.
And what else?
Well,
If a real math.
Hey, keep
Actually,
thought.
You did not say I hope you die, but that
Yeah.
reminded me. You just said, what is it?
Yes,
Yes, die.
yeah.
It reminded me we were driving to go run the Grand Canyon, and were in my aunt and uncle's place in Phoenix, and then it's like a 4-hour drive to get to the trailhead up to the Grand Canyon. And I was with my 2 cousins. We had gotten in late, stayed up till like 1 in the morning, left at 4 in the morning, and it was snowing, and my cousin Ian was driving. I was sick with like a cold, so I'm like, just passed out. Yeah, I mean, it's just brutal. So I'm in the passenger seat, passed out, and a couple times I feel the car like swerving and hitting rumble strips and like hitting slush. And I'm like, "Hey, you okay?" He's like, yeah, I'm good. I'm like, okay, whatever. I don't care if I die. I'm so sick. So we get to Flagstaff. We pull in. It's like now 6 in the morning. Pull into the gas station and stop. Ian gets out to get the gas, and all of a sudden this car rips through the gas station, this SUV, drives past us, and so he leans out the window and just yells, I hope you die. And it drives off.
Wow.
That's a little weird.
And we're like, what? Whoa, it's 6 a.m. Like, okay. So we go to the gas station, getting some stuff, and then as we're going to leave, this cop comes in the gas station and looks at my cousin and is like, "Are you Ian Lovett?" He's like, "Yeah, I am." And she's like, "Are you driving that car?" And he's like, "Yeah, I am." She's like, "Okay, can we talk?" He's like, "Oh, yeah, sure." She goes, "Somebody called in saying you're a reckless driver and just wanted to follow up with that." He goes, "Oh, yeah, I was downloading podcasts while driving." And I was definitely swerving all over the place. Probably bad idea. He was like, "Oh, okay, cool." And so what we figured was the people that called him in, or the people that drove to the gas station, they must have been following us as he was like swerving
Oh
around.
my gosh.
And they just
Quite
yelled,
angry about
"I
that.
hope you die."
Wow.
Someone's a little salty.
Yeah, all that. That just reminded me when you said, "Yes, die." To
Okay,
me.
good to know.
So I've been told twice now, "I hope you die," and "Yes, die."
I just thought of me and Keaton are like the 2x1 or 1x2 matrix of like the annoying constants.
Wait.
You're the only person. I'm like the variable who keeps you in check.
Regulates you,
Yes.
whether you're going up or down.
I'm the one who regulates you. If it weren't for me, you would be an utter disaster.
Okay, so what we do is, if you think about this, you don't need to write this, but if I have 4x is equal to whatever, 20, yeah, you can divide both sides by 4. We don't actually have division in matrices, but you can multiply by its reciprocal, or sometimes thought of as its inverse. So you multiply both sides by its inverse, right? And that would cancel, x is equal to 5. So in this case, what we want to do is multiply to solve for x and y. We want to multiply by its
Inverse.
inverse. Now, careful, over here, if we go this times its inverse, remember, if it's a 2x2 here, its inverse is going to be a 2x2. So if you have a 2x2 here, and you're going to multiply it, this is a 2x1, and you say, oh, I'm going to multiply by a 2x2.
That doesn't work.
Doesn't work, so where do I have to put the 2x2?
In front of it.
Yeah, in front of it. So when we go to multiply it, it's got to go on the inside. Alright, so let's go ahead and find the inverse of this. Now remember, a number times its inverse is equal to
1.
1. So what you're actually going to find out is, and I'll show it to you, but let's go ahead and find the inverse of this.
Okay.
Okay.
Maybe I should have just done that over here, make sure we're on the same page. 1 over the determinant, -3 minus 6 and -9.
Got one. Do that.
-3 plus 5 is 2 times.
Plus 5, no, there is no
Well,
5.
I'm like, where did you get that?
Oh, whoops, plus 6.
Another movie in the junior high.
Every class.
I'll have to deal with the fallout next year.
Oh.
Yes. Yeah, especially from our intelligence.
What'd you guys learn? Wally! Cool.
How many times did you watch that movie?
Okay,
Oops, okay.
did I do this right? I
Negative
did -3 minus 6,
Mhm.
-9. I switched the 1 and the 3,
Oh,
-1
whoops,
and the
yeah.
3, and then I changed the sign on the 2 and the 3. So what I would get, this is 5-2 there. Oops. What I get is, we'll distribute it in, you're going to get 1/9, 1/3, 2/9, and 1/3.
Whoa.
-1/3.
Oh, yeah.
As you do.
Now, what we know is
Oops.
if the left-hand side is xy, it's a 2x1. What does a 2x1 need to equal in the end?
2x1.
2x1. So we go ahead and say, okay, 2x1 xy equals. Now we multiply these matrices together. Yeah, it looks a little complicated, but there's because there's fractions, but it's going to work out nice and slick for us. Remember to multiply, you go row 1 by column 1. So it's going to be,
Oops.
we can do mental math on it actually.
0.5.
No, don't do decimals. And 0.5 is wrong anyways, sorry.
Okay, I'm not. Whoa.
How do you multiply?
5 9ths.
5/9
Mm.
plus.
Plus, I was right this time. 4 9.
4
4/9.
ninths.
What's 5/9 plus 4/9?
10
1
9ths.
ninth. One.
Which is
1/9.
0.99999, but
I didn't mean to say
one.
1 ninth. I meant to say 1.
0.999. What are we talking
Nine-
about?
well,
It's
9
one.
9.
5/9 plus 4/9.
It's 9,
One.
but just technically
1.
9/9.
1.
1.
One.
I didn't understand the
I don't know, my
0.999.
mom showed me this video where like, because like if you go.
Yeah, it's because 0.9 is.
But
or
0.9 is technically
1/9 is
0.9999999, but it's also 1, it's like a weird like
Oh wow.
theory.
Well, it's 'cause
Oh, you'll have to show me this. You
I thought
voodoo.
she showed me a video, I heard
Well,
about it,
it's
she's trying
just
to
like
explain
this.
it to me or something.
It's because if you do 4 divided by 9, you're getting out 0.444444444. And if you do 5 divided by 9, you're getting out 555555555. But then when you add the two together, you're getting out 0.9.
99999.
But then, because it will round,
But it's like, yeah, it's like a weird, it's basically the same thing as 1.
because they're both non-terminating decimals. Same thing with 1/3. If you have 1/3 plus 1/3 plus 1/3, it's
0.9999.
Okay, I'm done with this.
But it's like, obviously the real number of 1/3 isn't 0.33333.
It's 1. Top next
5/3
It's one.
minus
Yeah.
2/3 is 3/3, which is 1.
The number system you divide.
I'm so smart.
So then you look at this. Remember, a number times its reciprocal is 1, right? I told you, 1/4 times 4 is 1. So what happens is if we took this matrix times its inverse, which we have fully over there, we would fully expect it to be 1, except a matrix doesn't equal 1. By the way, I'm sorry, I didn't finish this. This is this. We did problems like this, right? X is 1, Y is 1. So let's do this. Let's take our inverse, 1/9, 2/9, 1/3, negative 1/3. Let's multiply that by its original, which was 3, 2, 3, negative 1, 3, 2, 3, negative 1. This should equal 1, but in matrix formatting. Okay? So go ahead and multiply this together. It should equal 1, but it'll be in a matrix format, so it's not going to actually equal 1. I don't know if the book mentions this in here, but that's fine. I'm going to mention it to you. So I don't know if they show this at all. Because this part isn't necessary for the problem. You know it just is gone, and you just have x, y is fine.
Oh, that doesn't work.
So you get
0/9 for one of these.
what do you get here? This row 1, column 1. What did you get out there?
1.
1, because it's 3/9 plus 6/9, so 1. And then you go row 2, column 1. You get 1 3/3 minus 3/3. What do you get about?
0.
0. And then you would get out row 1, so you get 2/9, row 1, column 1, right? 2/9 minus 2/9 is
0.
0. And then you get out 2/3 minus a negative,
1/3.
so a positive. 1/3, so 2/3 plus 1/3 is
1.
1. This is what we call, make a note of this, your identity matrix. Any square matrix with 1s in the diagonals going left to right, that's called the identity matrix. And it's the same way if you have 1 times 10. What's 1 times 10? 10. What's 1 times 14?
14.
14. Because 1 is the multiplication identity, right? 1 times anything, it keeps it the same. It's itself. That was a stutter.
Like Biden.
Now, what we're stating is that when you multiply this times itself, you ended up with the identity matrix. I didn't show it here, but 1, 0, 0, 1 times this. 1 times anything keeps it the same, so the identity matrix times anything stays the same. So this times this should equal that. Let's just check it real quick. Rows by columns, you would get 1 times x is
X.
x,
And then
0 times y is 0, so you're just left with x. Then you get 0 times x is 0, 1 times y is y, and you're left with that. Okay, so you don't actually need to show this in your work, but like on the test, if I say solve using matrices, and you just do a system of linear equations, you won't get any credit. You have to go and show me, hey, I found the inverse right here, and then I got 1 and 1 like that. You're only going to have to do this with a 2 by 2 versus having like a 3 by 3 or something like an x, y, and z, which gets a little more complicated. I don't necessarily want to do the problems. I think if you have this example, I think you're good to go. But I do want to make a note because you'll have a couple other problems that will look a little bit different, and I want to show you, make sure you can set it up correctly. So when you see a problem like this skis,
This is very interesting class. Okay.
x equals 3, negative x plus y is equal to 2. You're supposed to set up a matrix with this.
We didn't know why in the first one.
Okay, obviously not using a matrix would be super easy, but that's not the point.
Yeah.
It's back to the matrices stuff. So what would be our coefficient matrix, and then our variable matrix, and what's our constant matrix? That's an easy
What do
dubs.
you do?
What's our variable matrix? Easy dubs.
X and Y.
X and Y.
Well, why know this?
And then what's our coefficient matrix?
1,
One,
negative,
zero.
oh, yeah, 0.
Negative 1, 1.
There you go. Okay. So that's how you'd set that one up.
Okay.
Okay? Then one last one. We won't do it, but we'll just set it up. Well, I mean, we can do it if you guys so desire to practice the problems there within given to you on the board. But that will be up to thou dost desires, which I can imagine will be very limited.
Depends, is it in our problems or not?
I know what I do.
Oh,
What do you desire? Water?
Yeah.
you said that like. was
I
that
took a nap
biology?
the other day.
Whoa. Oh, okay. So you're just gonna add that one.
Okay, you're gonna add 1, 3, 2, 1, and then the point of this is, can you divide by a matrix?
No,
We have an ability
No.
to
Inverse again.
multiply by the inverse.
Absolutely not.
So add this over, and then multiply by the inverse.
Okay.
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 Okay. Good? Okay.
Which has
Cookie.
more numbers in it? A 1 by infinity matrix or a 2 by infinity matrix?
They have the same